Hello, this is my weekly summary. This week, even though I was absent for this class period, I did some research on how a semiconductor works, and especially is pretty much how a diode is, how a diode functions on the inside of it. This would be the symbol of a diode. This is what you would see on a schematic for a diode. Um, and usually the diode is a one direction. Um, it only works one way, so you have your anode, which is your positive side, and your cathode, which is the negative side. And it only works in one direction, which is usually the conventional way of doing it is from left to right, which is from positive to negative. Even though we know that the electron usually flow from negative to positive, but that's just a convention that we use. And so I actually try to go in depth, and I found um, that usually the way these works is because on the inside it's made out of silicon. So the ones that don't have anything here, I forgot to put it, but it should usually be the silicon. There's like pretty much like silicon crystals. Um, and usually, so what happens is we have silicon crystals on both sides of this. This area right here is called the depletion region, which means that we have uh, all it means is in this area there's really, so if we just have this without the battery, this would be a kind of like an insulator. That's why it's called a semiconductor conductor. So if we were to add phosphorus and boron on one side, which would usually call this N doping, or it means that there is, so when we add phosphorus, so for example the silicon here, it would have the 4 billions electrons in here. So that's why I did this right here. um, so it would usually have 4 on this one as well. But for the one that has phosphorus in it, it actually has 4 and then this extra one right here, for example. And then what it does is that since now we have an extra electron, this extra electron gets to move around, and it'll usually get really close to this area right here, to the depletion region. And then on this other side, instead of having an extra electron from, like, say an element like phosphorus, we have boron, which boron usually have 3 electrons. So when we replace a silicon molecule with a boron one here, what we would have is that we would have, instead of having an extra electron, we actually have a hole. So think of it like this one having 4 everywhere, like the ones that are just silicon. But where boron is, this red area right here, it would actually be a hole. Um, and this would call the p-doping side of the semiconductor, and that means that there's one less electron on that part. Um, and if you think about it, since we have one less electron, we can think of it as being positive because we have one more proton, but it's not really the case. And in this case, we have the extra electron. So what happens when you add the battery here, since we have the negative side as one electron goes into here, since it has the option to be able to move around, then we're gonna have holes on this side. But as more and more electrons go through this side here, then what's gonna happen, that this battery, if it's big enough, is gonna make it's gonna get rid of this. This pretty much will collapse, and so electrons are gonna be able to jump into here and fill in the holes. But what happens is that since we have electrons also on this side, even though I only drew the holes or the positive part of it, these electrons are going to leave, leaving more holes behind, and then they're gonna go to be attracted to the positive side of the battery. But then, so what happens is these electrons jump in here to fill the holes. Some of electrons leave here, um, because they're attracted to this side, leaving more holes in here, and that's how a semiconductor actually is able to carry the current. And these ones right here are usually, I think they call them like current carriers. So when we have when there's a depletion region, that usually means that there is no current carriers in here, because they usually all of the holes are filled, and so the extra electrons usually don't have a way to move. And so and that's how it would work for this semiconductor. Now, I mentioned in the beginning that usually this would only work one way, and the reason for that is because if you notice here, you have negative with negative and positive with positive, but over here you have positive with negative side, which is the N doping of it, and the P doping is on the other side. So what would happen in this case is that when we connect it backwards, the electrons on this side it actually get attracted to this positive side of the battery, and then leaving, pretty much gets rid of this electrons here. And on this side, think of it, these are electrons, extra electrons, and these are holes on the P side. And so since we have these, so on this side the electrons would be attracted to this, filling all the holes. So when we connect it the other way around, what happens with these type of diodes is that the holes get filled and then these leave. So we actually make this depletion region, we actually make it bigger. So that's why when you put it backwards, your semiconductor does not work. And so that's what I found out about these semiconductor, which is pretty mind-blowing if you think about it. And then this is my journal. This I actually did the same theme and explained it. And then I just did my reflection. But I just did this other picture just so that I can, I did it on my board here at home, just so that I can explain it. And then also this week I worked on our project, and I did all the soldering for it, put it together, and it's actually already working. It's just I forgot the battery. I forgot the battery at school, and so I don't have a way to make it work right now. But this is pretty much what I got. I just gotta get rid of these long wires and use the short ones to make it look cleaner, and it should already be good to go. And so this week pretty much I did spend about 5 to 6 hours outside of class just researching this stuff, understanding the diode, and then working on my project, making sure it works, and getting ready for the interview and all that. So this is it for my weekly summary. I hope it makes sense.